Class 11th Chemistry, Unit 5, States of Matter, and in this video we'll discuss about Dalton's law of partial pressures and partial pressure in terms of mole fraction. First come to Dalton's law of partial pressures. It states that total pressure exerted by the mixture of non-reactive gases is equal to the sum of the partial pressures of individual gases provided the temperature and volume remain constant. Okay. Now in this case, what is partial pressure? In a mixture of gases, the pressure exerted by the individual gas is called partial pressure. If P1, P2, P3, etc. are partial pressures of gases, then total pressure is given by P total is equal to P1 plus P2 plus 3 plus P3 plus and so on, providing constant temperature and volume. Let us see one example. In this container, oxygen gas is there. In this container, nitrogen gas is there, and the we can say pressure of oxygen gas is 159 mm mercury. Pressure of nitrogen gas is 593 mm mercury. Now both the gases are mixed. Clear? Now two conditions should be there. These gases should not react, that is non-reacting gases, and temperature and volume remain constant. You can see that volume of this container is also similar to this one and this one. Now in this mixture, whatever the pressure exerted by oxygen and nitrogen gas, that is referred as the partial pressure of that gas. Okay. Now according to this law, you can say that its total pressure of this mixture, this is the sum of partial pressure of oxygen gas and nitrogen gas, and this is equal to 750 mm mercury. Is that clear? Now application of Dalton's law of partial pressure. Gases are generally collected over water and therefore are moist. Now see, this is the one setup. We can also add one more, that is before this delivery tube there is one setup in that any gas is forming. Okay, gas is producing, and that gas from this delivery tube you can link with this. Okay, gas is coming from this manufacturing mixture. Now this gas through this delivery tube is collected in this jar, and in this jar, before starting the experiment, this jar is completely filled with the water. Okay, as soon as the gas bubbles move up in upward direction, water level come down. Okay, in this way we can say this gas is collected by the downward displacement of water. Okay, is it clear or not? What is the meaning of that? Gases are collected over water. This is the meaning. That is, when gas is formed, this bubble of gases displacing the water which is present in this gas jar. Okay, now again in this gas jar, along with the gas, water vapors are also present. Okay, that's why if we measure the pressure of this gas collected in this gas jar, this pressure is equal to the pressure of dry gas plus pressure of water vapors. Okay, now pressure of dry gas can be calculated by subtracting vapor pressure of water from the total pressure of the moist gas which contains water vapors also. Pressure exerted by saturated water vapor is called aqueous tension, and aqueous tension of water at different temperatures is fixed. That's why this P total can be determined experimentally. This aqueous tension we can find out because this is a fixed value, and if we want to find out the pressure of dry gas, then we use this formula. Okay, this is the application of Dalton's law of partial pressure. Now partial pressure in terms of mole fraction. First of all, we will try to understand what is the meaning of this mole fraction. It is the ratio of a number of moles of a particular component to the total number of moles of the solution. We are having one mixture, and that mixture contains two components, A and B. Okay, and number of moles of component A is Na, and number of moles of component B, this is Nb. Then, according to this definition, mole fraction of A is equal to number of moles of A in mixture divided by number of moles of solution. That is total number of moles present in that solution. We can also write XA. Actually, mole fraction is represented by X, and XA means mole fraction of component A. This is equal to Na divided by Na plus Nb. In the same way, mole fraction of B is equal to number of moles of B divided by number of moles of solution. That is XB is equal to Nb divided by Na plus Nb. I think this concept of mole fraction is clear to all of you. Okay. Now again one thing. Sum of the mole fraction, that is XA plus XB, is always equal to 1. Always equal to 1. More than two components may also be present in a mixture. Then also we will apply this. That is, sum of the mole fractions of all the components present in a mixture is always 1. Now we will try to find out the relation between partial pressure and mole fraction. Suppose we are having three gases, namely 1, 2 and 3. Number of moles N1, N2 and 3, and their partial pressures P1, P2 and P3 at the temperature T enclosed in the volume V. Then we can write this. P1 is equal to N1 RT by V. This is according to ideal gas equation. PV is equal to nRT. Okay. In the same way, we can write P2 is equal to N2RT by V. P3 is equal to N3RT by V. Then, according to Dalton's law of partial pressure, P total is equal to P1 plus P2 plus 3. Put the value of these P1, P2, P3, we will get this one. Okay. Now, in these three terms, RT by V is common. That's why P total is equal to N1 plus N2 plus N3 multiplied by RT by V. Now, on dividing P1 by P total. Now, we already discussed that P1 is this and P total is this. This is divided by this P total. We will get this one. P1 by P total is equal to N1 divided by N1 plus N2 plus 3, and this is multiplied by RTV divided by RTV. This is cancelled. Okay, and we will get this. N1 divided by N1 plus N2 plus N3. Okay, now what is this? This is the sum of the number of moles of these gases in a mixture, and that is given as N. That's why we can write N1 divided by N. Now again see, what is this ratio? Moles of component 1 divided by total number of moles present in the mixture. This is the mole fraction of component 1. Okay. X1 is called mole fraction of first gas. That's why we can write P1, that is partial pressure of component 1, is equal to X1 multiplied by P total. Get here? In the same way, if we divide P2 by P total, okay, we will get this. P2 is equal to X2 P total. In the same way, if P3 is divided by P total, we will get this one. In general, if I components are present, then we can write partial pressure of component I is equal to mole fraction of component I multiplied by total pressure. Is that clear? This is the relationship between partial pressure and mole fraction. Let us see one question. A neon dioxygen mixture contains 70.6 gram dioxygen and 167.5 gram neon. If pressure of the mixture of gases in the cylinder is 25 bar, what is the partial pressure of dioxygen and neon in the mixture? First of all, we will calculate the number of moles of dioxygen and neon. And how can we find out the number of moles? Number of moles can be find out, that is mass in gram divided by molar mass. Okay, this is equal to number of moles. That's why number of moles of dioxygen, this is mass of dioxygen is given 70.6 gram and molar mass of dioxygen is 32 gram per mole. If you solve it, we will get 2.21 mole. In the same way, number of moles of neon, this is the mass of neon divided by molar mass of neon is 20 gram per mole, and if we solve it, we will get 8.375 mole. Then mole fraction of dioxygen, this is equal to number of moles of dioxygen divided by total number of moles of dioxygen and neon, that is 2.21 plus 8.375. This is equal to 0.21. Okay, this is the mole fraction of dioxygen. Now in this case only two components are there, and we already discussed that the sum of the mole fraction of all the components in a mixture is equal to 1. That's why if we know the mole fraction of one component, we can find out the mole fraction of another compound. How? Like this. Mole fraction of neon is equal to 1 minus 0.21 is equal to 0.79. Is it clear? Now we can find out partial pressure is equal to mole fraction of a gas multiplied by total pressure. This is the formula. Now partial pressure of oxygen, this is mole fraction of oxygen is 0.21 multiplied by total pressure is given in the question 25 bar. If you solve it, we will get 5.25 bar. In the same way, partial pressure of neon, this is equal to 0.79 into 25 and we will get 19.75 bar. Okay, thank you.